the fourth part of the meeting today and discuss about some of the functions that we have for sleep in terms of memory, problem solving, some other aspects of sleep. So this is the fourth part of the class today, talking about sleep and memory. If I want to add another line to the table that we saw before, we know that we acquire information during wakeful activities. But it seems that there is a significant role for REM and non-REM in consolidating information in the brain or processing information in the brain. And as you can see here, the term that's being used here is iteration of information and then integration of information. And why there is a difference between iteration and integration, how these iteration and integration are working in the brain in a way that we can have better cognitive function, how they play a role in cognitive functioning that we are expecting from our brain. Let me just give you a few examples of how the sleep is important in terms of the processing that we have in the brain. First of all, we know that our sleep is sort of information selective. So when we have pieces of information before sleep, some of them could get stronger after sleep, and some of them could just get vanished. And it seems that that is the case for sleep, that sleep just goes for information that are tagged and relevant to our life, and they are important to be stored, and other pieces of information would just be erased. So the sleep is not going to work in something like a uniform way of just record whatever we have recorded before and keep them there after the sleep, but it is working in a selective way of collecting and kind of consolidating pieces of information. So it seems that sleep is going to be really important in terms of what we call information or memory consolidation. So it seems that kind of sleep is playing a significant role for consolidation. But it's amazing that, first of all, we know that we have different memories first. And we have different levels and stages of sleep. And it seems that different stages of sleep have different roles for different types of memories. So you can imagine the combination of interaction of these two factors in terms of different types of memories, different stages of sleep, and how they interact with each other is such a complex area for investigation. And we have good ideas about some of those kind of interactions, but we clearly do not know a good one-to-one map of this complex interaction between, let's say, all these different types of sleeps that we have, different types of memories that we have, and different stages of a sleep. That, okay, for example, shortwave sleep in this N3 phase, what will be the role of that in terms of, let's say, episodic memory that we have and how they are so how all these different types are interacting to each other. But in general, we know that there are definitely significant roles for different aspects of memory consolidation for sleep. And I'm going to give you more details in terms of how the system is working and what are the components and what are the processes that are happening in what we call a selective consolidation process during sleep. As you can see here, following the figure that I showed you, when we record information and we just record the kind of the consolidation of the process. If we just record the information, or we just test people in the wake or daytime activity, we just have the kind of limited amount of recorded information. But if we record things after the sleep, we know that the tagged information would have significant benefit from sleep. The non-tagged information would also be sometimes, so it is not always the case of vanishing the information. They could also get a little bit of improvement. But compared to something like the consolidation, that tag the information, relevant information, could get, they are much lower compared to that. So there are kind of variations for this effect as well. And just moving forward and giving you a better sense about how the information is being processed. So this is what we call the selective item consolidation. So having one piece of information gone and the other piece which is important for us being recorded. And then this is what we call item integration. This is the idea of during the sleep, when we have one piece of information, that piece of information would get into interaction with other pieces of information that we have recorded before, and is going to be a part of that schemata or that network of information that we had before, and just complete the picture there. So that is what we call item integration. And this is how the items would get integrated to each other. That is the process that we believe that would be happening. And if you remember, it seems that level of integration is highly related to the REM sleep. The other level would be what we call multi-item generalization. And what do we mean by that? It means that we have different pieces of information that are to some extent related to each other, so they can be connected to each other as something like generalization, saying that, okay, it seems that we have A, B, C, D, E, F, F, G, H, C, D, E, H, I, G. So there could be some relationships between these pieces of information. Meanwhile, we can make false memories based on this generalization and doing some overgeneralization to make false memories. We might be able to have what we call gist extraction. Basically, these pieces of information are alphabetic triplets, so that's the gist information from what we have recorded. And there might be some what we call rule extrapolation, whether LMN could be a part of this piece or not. So we can have extrapolation of rules, even we can have false memories, we can have gist extraction, and all these pieces are a part of the learning process. And that is the reason that when you learn something and you sleep over it, the pattern of information after you sleep would be far different compared to what you have recorded before, because there would be lots of generalization and integration and gist extraction and rule extrapolation and even some false memories that would be happening in this process that sleep is playing a significant role inside. So you should know that the information is being processed. And what we called here is not just consolidation, is a sort of evolution of memory. By evolution, I mean the evolution overnight. Something like overnight evolution of memory. That is happening in this process. And that is the reason that a good sleep is a significant important factor for learning. For learning, and by learning I mean the processing of information in a way that would be helpful for you to be able to use that information in something like a reasonable way in the next steps. The other thing that is critical in terms of the sleep processing, having an understanding about what we have been discussing about before. If you remember, we have been discussing about hippocampus and the interaction with what we call cortex. So we have been discussing that we have a temporary store fast in the hippocampus, and then we have sort of long-term stores in cortex. It seems that what we have during day activities would be recording things in hippocampus, and then the information would be slowly retained and consolidated and organized in long-term stores in cortex during night. So the hypothalamic cortical interaction is significantly playing a role in this process that we have during sleep. And that is the reason that, when we talk about dreaming, in my understanding, dreaming is a sort of byproduct of all these interactions. So because this system is functioning, and this system is just reading different pieces of information and putting them in different parts of this library, if you just turn on the light in the middle of the night and just let everybody get freeze in the process that they have been doing, you might see things are just in different parts of this library, and people were just reading different pieces together to see how these pieces are going to get along each other in different parts of this library. And it might seem even a little bit kind of bizarre or confusing or chaotic, but in reality that there are different processing that are happening to help you to categorize this information or consolidate those pieces of information to the pieces that you already have. So that is the reason that we have, if this process is getting interrupted and you see or you get conscious to these processes that are happening in your cortex and the interaction that you have between your hippocampus, thalamus, and cortex, and these kind of back and forth processes that are happening in terms of reading the information, encoding the information, consolidating information, putting these pieces of information into the library that you have in your cortex, you can just have let's say different perceptual experiences as your dreams, but they are those perceptual experiences would be just the byproducts of whatever you are doing in terms of encoding information and consolidating information, organizing information into pieces into the cortex. And that is the reason that we have been discussing about how slow wave sleep is interacting. And it seems quite interesting that, as I told you, we do not have this level of integration in REM. This is what we have in slow wave sleep. It seems that what we do in slow wave sleep, we just bring up information, find the piece of information that should go to different libraries, defining which library they should go, and just let's say we have a pile of books and information that should be categorized. In the slow wave sleep phase, you just define, okay, these pieces of information, you just open them, you just read the information again, and then you realize, okay, this piece of information should go to the, let's say, library number 2. So you just get the book and put it in front of library 2. And then the other book would go for library 3, library 5, all these bookshelves that you have, okay? You do this process, you do this iteration of information in the process of a slow wave sleep. So you categorize information under all those bookshelves. And then, during the REM sleep, you do not need that iteration and interaction between these pieces. Now you go for each of these bookshelves and just put the piece of information into this system and record that into this bookshelf. And that process needs a level of molecular integration of the information to that piece that is happening during REM sleep. So what we have a synaptic process that is happening in the level of, let's say, bookshelves. Okay? But here, we need to have a systematic consolidation at the level of the entire library to find the right place based on iteration of information that we make to find the right place and right order of information for each of these bookshelves. And then in the REM phase, now you know this piece of information should get integrated to this specific, let's say, bookshelf or series of books. And then you use all your synaptic mechanisms of using calcium and how calcium could make what we call long-term potentiation, long-term depression, and you record the information in the right place. So that is how people try to say that what would be the differential role between a systematic consolidation process in slow wave sleep, and then the synaptic process that would be happening in the REM sleep, which is quite different with what we have in slow wave sleep. Okay, that is kind of the end for this part.